Configuring access lists. I've always found the best way to learn access lists and to get familiar with the syntax is to do them again and again and again. It's kind of like subnetting. The more you practice, the better you get at it. So that's how I've structured this configuring access list video. I'd like to walk through 4 separate scenarios with you that take the concepts that we learned in the previous video and apply them in practical scenarios. Now, looking at these scenarios, they don't make much sense right here, but this is going to be what I'm testing on in each one of those scenarios as we construct a new access list for each one of those requirements. So, if you're ready, I'm ready. Let's get going. All right, here's our configuration landscape. You can see the 4 scenarios spelled out on the bottom of the network diagram, but before we even get into those scenarios and start working through each one of them and setting up the configuration, I'd like to talk a little bit about access list generalities. How do you configure access lists in general? You can see our scenarios are saying use a standard access list or an extended access list, but before we even accomplish those objectives, let's talk about just how to use access lists. What I'd like to do is take us to a router, and that will allow us to see this configuration, and I'll just walk through some samples, and then we'll do the real deal. We'll go through these scenarios one by one. So let me bring up the router connection and put it in the middle of the screen here. Just get things cleared off. You can see we're on router 3 right now to start things off, and this will just be, a nice generic place to go. To set up access lists, we're going to go into global configuration mode and use the command access list. Now, if you haven't gotten used to the context-sensitive help, the question mark as of yet, now's a good time. Access list will almost need you to use that going through there because very few people remember all the pieces off the top of their head. Now you can see all these lists. I type in access lists and it says, okay, type in a number 1 through 99 if you would like to create a standard access list. If you'd like to create an extended, go ahead and type in number 100 through 199, and that will configure one of those. Now you can see as we go through this list, there's plenty of other ones like IPX access list, MAC address access list. You can permit or deny based on MAC address. But a lot of these protocols we just don't use anymore, like IPX or DECnet. So we're going to stick to IP access lists. Now you can see right here we've got the standard and extended, but notice right here, and right here is an IP access list for standard and extended in an expanded range. So what they're saying is if you run out of lists, meaning you've exceeded 99 lists, number one, I'll tell you, you've created way too many access lists if that's the case, but Cisco says we'll let you do it. Here's 700 or so more access lists that you can create using that expanded range for each one of them. So let's start off with the standard extended access list. I'm just going to say access list 1. I could type in any number from 1 to 99 and it would work just fine. I'm just using 1 because I like it. So I hit the question mark and it says, okay, is this going to deny or permit? Or would you like to leave a remark in this access list? So we'll say this first entry is going to be a deny entry. Remark, by the way, just leaves comments so you can see what the access list is about. So I'll type in deny, hit a question mark, and it says, would you like to match a host name if you're using DNS? Very few people do that. Or an IP address. Would you like to match any or a single host? So this is our big option. Let's say that I would like to deny, and we haven't talked about our scenarios yet, but I want to deny the host 192.168.5.100. Just a nice random IP address. I'll do space question mark, and now it's asking me, what are your wildcard bits? Wildcard bits. Where did we see that before? OSPF. The Open Shortest Path first routing protocol, we had to type in the wildcard mask to type in what networks we would like to advertise. And now they're back to haunt us. Wildcard bits are going to designate what is significant about there. Meaning, do you want to match that exact IP address? If so, go ahead and put 0000. Meaning, look at, and you remember the wildcard bits? 0 means look at these. Look at 192. Look at 168. Look at 5. Look at 100. When that IP address comes through, identify it exactly. And if that's it, deny it. Now, I could also go here and make it a little more broad. I could say 192.168.50. Well, I wouldn't put 50, but if I did this, what that says is deny everything starting with 192. Look at that first octet. 168. So everything starting with 192.168, and then I don't care is what those means. Watch what happens. I'm going to hit enter, and then I'm going to type in show access list using the do command so I can do it from global config mode. Look at what it did. It said deny 192.168 00. You catching that? It zoned out, it wiped out my 5.100 because it said, I don't care what those are. You put 255s there. Now, if I were to go back up there and do no access list 1 deny, remove that and try it again, and I put 0.0 right there, and then do my show access list. Now it's just saying specifically that host is there. The wildcard bits disappear because if you notice, it says you could put a return key after the 192.168.5.100, and it would assume you're talking about that specific IP address. This wildcard mask of all zeros is optional. Matter of fact, let me hit the up arrow and put a no in front of that, wipe that out. I could type in access list 1, deny, and check this out. I could say host 192.168.5.100, and now when I hit question mark, it doesn't even give me the option for a wildcard mask because I've specified just that host. So what I've showed you there was essentially 2 ways to accomplish the same thing, 3 ways to accomplish the same thing of denying a specific IP address. So that's essentially our line 1 of the access list. Now I'm going to go in there, I'm going to say access list 1, it's the same list, permit 192.168.5.0 with a wildcard mask of 0.0.0.255. Now let's do a show access list. If we could type. Now right here, you can see first entry, or what the router is calling sequence 10, when we'll talk about those numbers in just a moment. First entry says deny 192.168.5.100. Second line says permit everybody else that starts with 192.168.5. So that's how we create a standard access list, is we just identify the source IP addresses we want to permit or deny. Now remember, think back to the rules we talked about in the previous videos. At the bottom of this access list is an implicit invisible deny, meaning if you are not something that starts with 192.168.5.0, you will be denied. You will be prevented from accessing whatever this access list is preventing you from accessing. Speaking of that, let's apply this. Creating access lists you could do all day long, but they won't actually go into effect until you apply them. So you've seen the access list command. Here's how you apply. Go back to that network diagram, and we're on router 3. We need to identify what direction we want to apply from. Let's say that we want to protect router 3 from receiving messages from that host that we denied, 192.168.5.100, right? So I can apply it inbound on serial 0/0. Remember, hold out your arms, just like I talked about in the previous video. Identify your direction as things are coming in that serial interface. That's where I want to deny that specific host. So that's where we need to apply it, serial 0/0. So let's jump into interface, serial 0/0, and here's the apply command. IP access-group. I don't know. I know you're thinking, I thought it'd be access list. I don't know why they chose access group, but they did. Access group applies it, and it says, what access list number would you like to apply? And you think, well, I configured access list 1, so let's apply that. I'll put access group 1, question mark, inbound or outbound. Well, we identified on that network diagram, we would like to filter it as it comes into our router. So I'll put in, question mark, it says go ahead and press return. So now I have applied that on router 3. It is allowing, let me do a show, hang on, let me put do show access list. It is allowing anything with 192.168.5.0 to come in, or that 5 subnet to come in, and this host, that specific host, will be denied. Also, the implicit deny catches everything that does not start with 192.168.5.0. So you see a message come across the screen. Look at this. Neighbor 192.168.2.1 is down. The hold time or the dead timer expired. Want to know what just happened? We just severed connectivity to router 3. The neighbor, 192.168.2.1, is speaking of router 2. It just says, I lost my connectivity to router 2. The reason why is because router 2 was coming in and EIGRP was sending hello packets sourced with the IP address 192.168.2.1. Well, according to our access list, the implicit deny is killing anything with 192.168.2 because it doesn't start with 192.168.5. You see how dangerous access lists can be. I'm going to hit the up arrow and undo that. I'm going to do no IP access group 1 in, and we should see our neighbor relationship restored with EIGRP. See, now we're up. We're back online because we're not coming from that. So that's that. I just wanted to give you, before we get into the scenarios, the general syntax of working with access lists. Now, with that in place, let's look at scenario 1. Use a standard access list to block host A from accessing host B. And I have these hosts in place. We're going to be able to test this. Host A accesses host B by going through router 2, through router 3, out, and then ping right here. Now, I don't have his IP address. Let me wipe that off. Host B is .50. 192.168.3.50. So I'd like to start things off by going to host A and doing a ping to host B to make sure that we can access it right now. Host A is right here. The role of host A will be a remote connection to my laptop. So let me just do an IP config on this guy. And you can see that I have the local area connection. That's my LAN interface. 192.168.10.50. Jump back to the network diagram. 192.168.10.50. So this is host A right here. Now you can see the wireless connection. This is how I'm connecting to it via remote desktop. Just because these laptops are in another room, you can ignore this whole thing right here. Pretend it just does not exist, because this is the interface that's actually being used. You can see this one doesn't even have a default gateway. So, right. So I'm on host A, and I'm going to do, I'll even do one better than a ping. Let's do a trace route to host C, correct? Host B. Host B is 192.168.3.50. 192.168.3.50. I'm going to do a trace route -D, otherwise it takes forever. All right, so we can see that host A went to 192.168.10.1, then 2.2, then 3.50. Let's verify that against the diagram, starting off with 10.1. So host A, it's in a VLAN, so it came over here to its sub interface right there, 10.1. The router took it and routed it back out over here to 2.2. There's 2.2. And then it finally hit the host 3.50 over there. So it is taking the correct direction to end up reaching host B. Good. Now, I also have a remote desktop connection to host B, which is over here. Let me just bring it into the window. This is host B. Again, I have an IP config already up. There's 3.50. And I'm going to do a ping to, well, let's do a trace back. Trace route 192.168.10.50. That's our original host. Trace route -D. Otherwise, Windows tries to look up those IP addresses and figure out their name. There we go. That's what we thought. 3.1, that's the Ethernet interface. 2.1, that's the WAN link. So 3.1, 2.1, and then it's getting to host A. So we have verified both host A can access host B. Now, objective. Use a standard access list to block host A from reaching host B. So I think the first thing I want to do before we even get there is just pen this out on paper. It's always good to write down your access lists on paper before you put them into the command line interface, and that goes for most configurations. So I want to create an access list that blocks host A from accessing host B. I'm going to use the command, just like we had before, access list, access-list, 1, or we'll use 10 for this example. It's just a number. And I'm going to say deny. Now remember, a standard access list can permit or deny based on source, only the source IP address. So I'm going to put deny host. Remember that shortcut I just showed you a moment ago? Deny host, and then I'll put the IP address, 192.168.10.50. which is deny that host, right? So that's what our access list should say. We should be denying it. Now, with a standard access list, you cannot say denied from what, because that's destination. That's what you need an extended for. So all we can say is that host is denied. Now, a couple things on that. If you have an access list that is only denying something and you apply it, you have denied everything. Think through it. Do you know why? Because at the bottom of every access list is the invisible implicit deny. So an access list that only has deny statements in it will effectively deny everything if you permit. I mean, if we were to apply this, we'll say, right here, outbound or something in that case, it would check it, would say, okay, are you this host? Because if you are, you're denied. And then it would go to the next line, which is invisible. It's a deny everything. And it says, oh, and by the way, if you're not that host, you're also denied. So that's a grave warning to you, because I've done this many times where you'll be on a router, you're quickly going through the config, you're like, oh, I just need to deny this one thing and deny to apply, and wham, the router connection goes down. So we need to follow this up. I'll say access list 10 permit, and there's a couple ways we can do this. Let me bring us back to our router here just to show the syntax. Access list 10 permit, and I'll do a question mark. Now you can either do it one of two ways. Permit any, says any IP address. So going back to this, we have 10 deny host here, and then we could put permit any. Let's try and squeeze it in over here. Permit any. And that would allow everything else, so the implicit deny would never be reached. We can also put access list 10 and permit the IP address 0000 and follow it up with a wildcard mask. Which one do you think? To permit anything. That's it. 255, 255, 255, 255. You're saying permit this IP address, and then I don't care, I don't care, I don't care, I don't care. Watch what happens if we do that. I'm going to type in show access list. And then I created access list 10. But look, the router recognized it. And it goes, oh, well, you typed that in, but you really meant any. Now, I don't want you to think one's better than the other. One's definitely shorter, but they're both equal. You can type it in either way. That'll work fine. So I'm going to do a no access list 1 and a no access list 10, because there's still one more thing we have to figure out. This is the access list we need to create. Now my question to you, where do we put it? And in what direction do we apply it? If you want to, please pause the video and think through that. Identify where we're coming from and identify where we're going to. Okay, pause now. Okay, you're back, right? You've paused it, right? No, you didn't pause it. Pause it. Okay, now you're back. Host A right here is going to be accessing host B. There's four different places that we could apply this. We could apply it as host A comes in to its default gateway. This is a valid place to apply that access list. I could apply it on fast Ethernet 0/0.10 inbound. Now, if I did that, I mean, I know we've got VLANs here. It's a little not as clear as what it would be if we didn't have VLANs, but by applying this in, it would be as if host A were connected to its router, and we said, okay, as you come in your default gateway's IP address, you will be denied. If we do that, well, will we accomplish our objective? Yes. Host A will not be able to access host B. However, host A will also lose access to everything else. We've denied too much. So we can't apply it in right there. We could apply it out right here. And that, as host A, when came in that interface, it would start routing them. But as it saw, oh, I'm going to send you out this link, it would be denied. Problem with that? You've denied too much. Now, I know in this picture right here, it looks like, oh, well, that would accomplish our objective, and it would. But what if router 3 had another connection to, some other router down here and some other network that we didn't want to deny host A from reaching? Well, then we've denied too much. So let me just keep that imaginary network there for now. So other potentials, we could apply it inbound right here, but same problem. As soon as he tried to come in router 3, he wouldn't be able to get out to this mystery network over here. The best place to put this is as he goes out. Again, hold your arms out. You are a router. As the host A goes out the router 3 Ethernet 0/0 interface, it's going to say you are denied. Now, the argument could be, well, what if there's other hosts on that network? Well, unfortunately, using standard access lists, that's the best that we can do because we can't say what he's denied from. So the best practice, and here's the rule that Cisco recommends, the best practice with standard access lists is to place them as close as possible to the destination. Whatever destination you're trying to access, put it as close as you can to there. Because if you put it too close to the host, too close to the source is what I should say, you may deny them from too much. Since we can't say what they're denied from, they have to get all the way across the network to near to the destination just to find out they're dropped. It's kind of a bummer. Host A is all excited, I'm going, it's crossing the WAN link, I'm getting to the router, and wham, dies as soon as it tries to exit that interface. But that's all we can do with the standard access list. So let's make it happen. Again, let's try it one more time just to make sure we're working. I'm going to ping 192.168.3.50, and we are working. This is from host A. So with that in place, let's go to router 3 and put this in action. I'm there right now. I'll do access list. Let's use 25. I like using nice random numbers. Remember, we're specifying a standard access list. I'm going to deny the host 192.168. He was 10.50. I don't know why I keep forgetting that. 10.50. So we follow that up with access list 25 permit any to permit everybody else because an access list of all denies everything. Get into interface, and what interface was that? Let's do a do show IP interface brief, my all-time favorite command. Oh, look at all those loopbacks. This is the 192.168.3.1, Ethernet 0/0. Interface Ethernet 0/0, and here's the command, IP access group 25, that's the access list number we want to apply, and the direction will be out. I want to make sure I emphasize that one more time. As somebody is going out this interface, be the router, be router 3, hold your arm out. Your right arm is Ethernet 0/0. As somebody tries to leave your right arm, if they are the source, 10.50, they will be denied. Now, let's watch it happen. Let's go into that host, hit the up arrow, and do that ping again. Look at that. We were successful up here, and now it is coming back. Destination net is unreachable. Reply from 192.168.2.2. Who is that? That's router 3. Sweet. So it's working. Now watch this. I'm going to go back to router 3, and I'm going to do my favorite verification command for access list, show access list. It's simple, it works, and it even shows how many matches you've had on each one of those. It has denied 10.50 8 times. 8 times when it was trying to access that host. Now you can see 8. Let's just hit the up arrow and do that ping again. Whoa, holy cow. That was insane. While that ping was going through, I was trying to be fast. It didn't work. Look at that. 16 matches. So what does that tell me? It tells me that Windows Vista is sending 2 ping packets every single time it tries to ping. It shows 4 of them, but it must be sending 2 ping packets each time because each time I do this ping, you can see the counters increase by 8. Interesting. I learned something new about Windows Vista. So with that, that's how we have accomplished scenario 1. Block host A from accessing host B. Holy cow. Look at that time. I get so into this. Let's make this video an hour. No, let's not. Here's what I'm going to do. I'm going to do scenario 1 and 2 in this video. And then we'll do scenario 3 and 4. I'll make a part 2 to the access list configuration because I'm not going to do it. I'm not going to make it through extended access lists and meet my 30 to 40 minute time buffer. All right, so scenario 2. Use a standard access list to prevent host A from telnetting or SSHing to router 1, essentially managing it remotely. What I'm showing you as I do this is an extremely common use of standard access lists. By default, Cisco routers allow anybody to telnet or SSH into them as long as they have the right username and password. Now, couple that with a problem. Cisco routers will let you try passwords all day long, meaning they're not going to lock you out after you miss the password 3 times or 5 times and you have to, call an admin or something like that. They'll just let you keep trying until someday somebody's going to figure it out and break on in. So, what a lot of people will do is only allow certain hosts to telnet to the router. Let's see, we're on router 1, right? Router 1 as of right now, let's just verify. Host A. Let me clear the screen. Host A can ping router 1, 192.168.1.1. That's router 1. And I'm going to telnet 192.168.1.1. I was like, oh no, he can't. He can't. There he is. So please don't log in. Oh, he guessed it. He's in. So he is able to access router 1. So our goal is to deny or prevent host A from telnetting or SSHing to router 1, but not affect any other access. Meaning, if we were to apply a standard access list just like we did on router 3, saying deny 192.168.10.50 inbound on router 1, well, host A, sure, he wouldn't be able to telnet into router 1, but he wouldn't be able to access the internet anyway, either. He wouldn't be able to do anything. He just, as soon as he got to router 1, he'd be blocked. So you can apply a standard access list not only to an interface, but you can apply it to your VTY ports. Let's go to router 1 and I'll show you how. Pull up my connection here. Still on router 3. Let's hop on over to router 1. All right. Let's get all this out of our mind because we're done with router 3. All right, we're sitting on router 1. I'm going to do, well, let's just go right into it. Let's create the access list. On router 1, I'm going to type in access list, and we're using still a standard access list, so something from 1 to 99. Access list 70. Now, as a side note, made me think of it when I hit the question mark. I don't know if you remember, but when I hit the question mark on router 3, do you remember it had those IPX access lists in there too? We don't see those on router 1, and it's a simple reason. Router 1 has an iOS version, a software version, that doesn't support the IPX protocol or the DECnet protocol. You might have saw me highlight that one when I was on router 3. That's because those are old, and router 1 is new. It has a new iOS version, and they've discontinued support for those protocols. People don't use them anymore. So I'm just going to use access list 70. So standard access list, question mark, permit or deny. Now, before I go any further, let me first mention there's usually a little better strategy with picking access list numbers than what I'm showing you right now. Right now, I'm just kind of randomly going in being like, let's throw a dart at the dartboard. 70 sounds great. Usually people will go in order and they'll say, okay, 1, access list 1. Okay, when they're done with that one, they'll start and create another one, 2, and so on. Every access list could have hundreds or even thousands of lines in it. So there's practically no real limit on how long an access list can be. But do remember that once you apply an access list, all those lines will take effect. So let me show you using a remark. I'm going to type in access list 70 remark. Question mark, it says comment up to 100 characters. I usually put my remarks in all capitals. This will deny host A from telnetting to R1. So we just put a nice little comment in there. Now I'll follow that up with, turn off my caps lock, access list 70, deny, and we'll do host A. And I'll do it a little different this time. I'll do 192.168.10.50. That's host A. Follow that up with that wildcard mask of 0000, which says specifically that host. Good. So I'm going to hit enter. I've put in the deny. Now remember, we have to add at least one permit statement. So I'll say access list 70, permit everybody else, permit any. So it's the identical access list to what was on router 3. I'm going to type in show access list 70. And you can see there it is, access list 70. Oh, this iOS version doesn't show the remarks. Let me do a show run include lines that have access list 70. They will show up in the running config. You can see that that's where we see our remarks. And some of the other iOS versions will actually put the remarks in the show access list command. So, okay, so we've got the access list. Now, the question is, where do we apply it? I already told you we can't apply it to the interfaces of router 1, or else we would block host A from reaching the internet, and we'd block too much. So what we can do, and this is a very unique feature for standard access lists, we can go under our VTY ports. Remember VTY, line VTY 0 space 4. That's our telnet ports. It may have been a little while since we've done that. So I'm under the telnet ports, and I want to apply an access list to the telnet ports to prevent who can come in them. So I'm going to type in, and again, we go back to the question, why did Cisco use IP access group to apply an access list to an interface? And you'll have the same question because the command's different. They use the command access-class to apply an access list to VTY ports. They don't use access group, it's access class. It's functionally the same as the access group command. It's just for whatever reason, you know, the developers at Cisco were up a little late one night and they're like, hey, why not? Let's make it access class. So I'm going to type in access, and also notice there's no IP on the front of that one, just access class, unlike IP access group. So I'm going to type in access class. I want to filter this using access list 70. And I want to filter incoming connections. As people are coming in or telnetting into this router on these VTY lines, I want to filter them based on that access list. 99.99999% of the time, you will always apply access class in the inbound direction. If you apply them outbound, weird things can happen. That's where you will suddenly randomly not be able to telnet certain places from your router for some strange reason. So we're filtering it in. All right, cool. I'm going to type in show access list 70. Check it out. We see it right there. Looks good. Let's now go back to our client. He's still on the router, so he's got an existing session I'm going to kill. Hit the up arrow, telnet to 192.168.1.1, denied. Try it again, denied. Totally denied. And I'm coming back here to my, my session with router 1, do the show command, and you can see the deny has now been matched 6 times for telnet access. That tells me, another interesting fact, every single time I try to telnet with Windows Vista, it sends 3 packets, 3 attempts to try and open that session before it finally says connect failed. Now, okay, that's good. That's good. We denied host A, but what about the other host? Could host B access that router? Because we didn't want to deny host B, right? Well, let's try it out. I'm going to bring up host B right here. This is host B. 3.50, and let's telnet from host B to 192.168.1.1. And look at that. Host B can still get in. And while we're telnetted in on host B, let's try this. I'm going to do a show access list because we should see, oh, don't look at that. You did not see that. That's for the next video. Show access list 70. Look at this. Access list 70 is our telnet access. Still got the 6 denies for the 10.50, but look, now the permit is getting matches as well, showing that host B over here is being permitted to enter that. Good. So we now have completed scenario 1 and scenario 2, prevented that, and blocked telnet access for host A. I'm going to freeze frame that network diagram with the first 2 scenarios completed as we transition into the next video, which is going to pick up right where we left off. We've now completed standard access lists. Again, standard access lists are fantastic because they're very easy on your processor, but very limited in what's possible of denying only on the source address. So most people will use them for functions like VTY access, where you apply it is very specific and you don't accidentally prevent somebody from reaching too much. In the next video, we'll pick up with the extended access list. I hope this has been informative for you, and I'd like to thank you for viewing.